For number 6, this is the one where it's asking us to consider this exponential equation or function, and if we were to graph it, which following value of x would produce a point closest to the y-axis. So before we actually look at these points, let's think about the shape of this. So we know it's exponential because it's like this. So we know it's going to be L-shaped, either like that or like this. So which one is correct? Well, it depends on if it's growth or decay. And since 1/2 is smaller than 1, then we know it must be decay. So that tells us the shape of our graph is actually going to be like this. Right? Remember, it's the shape of like your left hand. Right? So I guess that's like your left hand. So it's going to have that shape. Now our goal is to figure out which point on my x-axis is going to be closest to the graph. So let's see, does it get closer as I go to the right and larger x's, or does it get closer as I go farther to the left? And we can see on the right side, we are definitely much closer on the right side, or on the larger values of x, than on the left side. So that means I'm just basically looking what's the largest value of x in here. And if I can compare it, well, some of you guys may be able to see that c right away is the largest. If you're not quite sure, then do the long division, or do the common denominators. So I'll do common denominators. I'm going to get it to a denominator of 6. So this is 5/6. If I multiply by 2, this is 4/6. And if this one I multiply by 2, I'm going to get 2/6. This was 5/6, and this one, well, it's already small, we can tell. So the biggest number is 5/6, so that's going to be our answer. Another way you could have done this is by getting decimals. So 2 divided by 3, it goes in to add that decimal. We can get that going in 6 times. 1 divided by 3 is 1/3, or 0.33. 5 divided by 6 goes in 0 times, so we add the decimal, and it goes in there 8 times. So we can see already 0.8 is the largest number. So that's going to be the number that's closest to our x-axis.